Welcome to the stage, NVIDIA founder and CEO.
People talk about AI reducing jobs, complete nonsense. It's causing more software engineers.
Welcome back, everybody. Jensen is here, of course, the CEO of NVIDIA. This is the clear winner of every winner.
The year is 2002. NVIDIA, a graphics chip company in Santa Clara, California, has just lost half its revenue in a single quarter. Its stock has fallen 90% from its peak.
NVIDIA has lost nearly $420 million in revenue in a single quarter. Sales have been cut almost in half. The stock has crashed 90% from its peak. Wall Street has already declared NVIDIA dead.
CEO Jensen Huang is sitting in his boardroom, staring at a set of numbers that tell him he has approximately 3 months of cash left. He has a decision to make. He can pivot, cut costs, shrink the company, focus on the narrow gaming chip business that still has customers. Or he can bet everything on an idea that nobody in the technology industry believes in. He bets everything. 22 years later, NVIDIA is worth $3.34 trillion.
Been another record-breaking day as a chip-making giant NVIDIA broke the $3 trillion valuation mark.
He bets everything, more than Apple, more than Microsoft.
This company is now worth more than most other countries' GDP in the world. It has, in fact, surpassed Australia, South Korea, even Russia.
The largest company by market capitalization in the history of capitalism.
NVIDIA is the belle of the ball. Today's gain was yet another record high.
So it's a really, really fast rise in a very short amount of time.
The chip that Jensen Huang bet on, the one nobody believed in, now runs every major artificial intelligence system on Earth. ChatGPT, Google Gemini, Tesla Autopilot, Meta's AI, Amazon's cloud. All of them run on NVIDIA. But here is the part nobody tells you. NVIDIA did not invent AI. It did not create the algorithms. It did not write the code. It made the chip that made AI possible. And it did so 16 years before anyone knew that AI was going to happen. To understand NVIDIA, you need to understand what a GPU is and why it is different from everything that came before it. A CPU, the processor in your laptop or phone, is like a brilliant general. It processes tasks in sequence, one after another, with extraordinary intelligence and flexibility. A GPU, a graphics processing unit, is different. It is not intelligent, it is massive. It runs thousands of simple calculations simultaneously, in parallel, at the same time. NVIDIA invented the modern GPU in 1999. At the time, it had one application: video games, rendering the pixels on your screen, nothing more. But here is the thing about running thousands of calculations simultaneously. That is also exactly what you need to train an artificial intelligence model. NVIDIA's H100 GPU, its flagship 2023 chip, costs between $30,000 and $40,000 per unit. It has 80 billion transistors. It consumes 700 watts of power. Companies are ordering them 10,000 at a time and waiting 12 months for delivery.
The GPU of DGX is 8 H100 modules. H100 has a transformer engine designed to process models like the amazing ChatGPT, which stands for Generative Pre-trained Transformers.
Microsoft spent $10 billion on OpenAI, the company behind ChatGPT.
Microsoft is to boost its investment in ChatGPT maker OpenAI. This isn't entirely a surprise. Some folks last week were talking about the idea that this could happen. This will be the third investment in about 3 years.
But before Microsoft could deploy ChatGPT to its customers, it had to spend an estimated $10 billion on NVIDIA chips to run it. OpenAI made the product. NVIDIA sold the factory. Jensen Huang likes to say that NVIDIA is in the business of accelerated computing. What he means is this: whatever the world wants to compute next, Weather models, drug discovery, self-driving cars, artificial general intelligence.
You know that we're producing tokens. We're producing floating point numbers at high volume for the first time in history, and the floating point numbers have value. The reason why they have value is because it's intelligence. It's artificial intelligence. You can take these floating point numbers, you reformulate it in such a way that it turns into English, French, proteins, chemicals, graphics, images, videos, robotic articulation, steering wheel articulation. We're producing tokens at extraordinary scale.
The world will need NVIDIA chips to do it. The chip is the infrastructure, and NVIDIA has a near monopoly on it. Jensen Huang was born in Taiwan in 1963. His parents sent him to the United States at age 9 to what they believed was a prestigious boarding school in Kentucky. It was not. It was a reform school, essentially a school for troubled children. Jensen Huang spent his early American years doing chores at a reform school in rural Kentucky. He survived it. He went on to study electrical engineering at Oregon State, then got a master's degree from Stanford. In 1993, at the age of 30, he co-founded NVIDIA with two friends from work, Chris Malachowski and Curtis Preem, with $40,000 in startup capital.
Huang, I'm the president and CEO of NVIDIA. I met Chris and Curtis. They were at Sun Microsystems. I was at LSI Logic. So we were all from the workstation industry, and all we had ever worked on were Sun workstations and had valid workstations and things like that.
I don't need to change the world overnight. I'm going to change the world over the next 50 years. I don't need to build a killer product overnight. I just need to build a winning product. And the goal of winning is so that you can play again. It's just like pinball.
The founding pitch was simple. Personal computers were about to need graphics chips. The visual complexity of games and operating systems was growing faster than what existing chips could handle. NVIDIA would make a better chip. NVIDIA's first product was a failure. Its second product was a partial success. Its third product, the Rivi 128, released in 1997, was a hit. By 1999, NVIDIA had gone public, released the GeForce 256, which it called the world's first GPU, and was competing directly with ATI and 3DFX for dominance of the gaming graphics market.
I'm Phil Scott. I've been at NVIDIA 21 years now. I'm the Director of Developer Relations in Europe. I worked at Rage back from 1996 through to late 2000. It was a great place to be at the time. The place was full of industry luminaries, and it was a really exciting time. It was at the advent of GPUs. One of my colleagues had basically had a lot of success with a game called Incoming, which I think a lot of people will remember now.
The dot-com bust of 2000 to 2002 destroyed NVIDIA's revenue base. PC sales collapsed. Gaming demand evaporated. NVIDIA was burning cash it did not have. Huang made a brutal decision: lay off 500 employees, a significant fraction of the company, and eliminate every project that was not absolutely core. But rather than retreating entirely, he doubled down on something that seemed, at the time, completely irrational. In 2006, NVIDIA made a decision that, for the next 6 years, was almost universally regarded as a waste of money. Jensen Huang decided to turn NVIDIA's GPUs into general-purpose computing platforms.
So we wanted to make our graphics processors more and more general. And the reason for that in the beginning was because some of the effects that we had to do related to general-purpose image processing, post effects. You render the image and you do post image effects.
He hired hundreds of software engineers. He built a programming framework called CUDA, Compute Unified Device Architecture, that allowed researchers and developers to program NVIDIA GPUs for non-graphics tasks.
What's really surprised you over the last 5 years in terms of how CUDA's developed and how people have used it? And I'll throw one thing out there. I think the day that I was disclosed on CUDA right before it launched, if you'd asked me at the time, I would have said, in 5 years, maybe people aren't going to be programming so much in CUDA. Instead, people are going to build higher level languages on top of this, and that's what we're going to be using. But CUDA is really proven to have legs and is a very efficient way to keep these machines busy with lots of work to do.
Applications for computing in tons of spaces. And we have a vision of, if computation is free, what would that mean? And what would it mean for everyone? And we can inspire ourselves. But there are all these short-term things that we can go achieve with GPUs that were simply just not, no one thought of. There were maybe a small group of people out there that were researching.
The gaming GPU market was growing, and CUDA was being given away for free to researchers who were using it mostly for academic projects. The people who understood what CUDA could do were a tiny community of academic researchers working on machine learning.
CUDA is a parallel software programming environment for programming GPUs with C. And when you write a CUDA program, it allows you to use all the parallelism of a GPU and write a program which executes on many, many, many threads in parallel and use the tremendous floating point.
A field that, in 2006, was considered a backwater of computer science. Most serious AI researchers had abandoned the idea that neural networks would ever be practically useful. In 2012, 3 researchers at the University of Toronto, Geoffrey Hinton, Ilya Sutskever, and Alex Krzyzewski, used NVIDIA GPUs programmed with CUDA to train a neural network called AlexNet. AlexNet entered the ImageNet competition, the world's most prestigious computer vision challenge.
In 2012, Ilya Sutskever and Alex Krzyzewski and Jeff Hinton in the University of Toronto, the lab that they were at, they reached out to a GeForce GTX 580 because they learned about CUDA and that CUDA might be able to be used as a parallel processor for training AlexNet. And so our inspiration that GeForce could be the vehicle to bring out this parallel architecture into the world, and that researchers would somehow find it someday was a good strategy.
And won it by a margin that was, by the standards of the field, incomprehensible. Its error rate was nearly half that of the second-place entry. Jensen Huang had been waiting 6 years for this moment. CUDA was already deployed. The software ecosystem was already built. Researchers who wanted to use GPU-accelerated deep learning did not need to figure out how to program a GPU. They could use CUDA, which ran only on NVIDIA hardware, and was not an accident. Huang had designed it that way. Every researcher who learned CUDA, every research paper written using CUDA, every company that built its AI pipeline on CUDA was a company that could not easily switch to a different chip. The switching costs were enormous. The moat was not the chip. The moat was the software. By 2017, NVIDIA had established dominance in the AI chip market. Its data center revenue was growing faster than its gaming revenue. Jensen Huang was being called the most important CEO in technology.
Jensen Huang's leadership had made him one of the most admired CEOs in Silicon Valley.
Industry experts were now calling Jensen Huang the most important CEO in tech.
NVIDIA's Jensen Huang. NVIDIA's CEO Jensen Huang. NVIDIA CEO Jensen Huang.
To Silicon Valley to meet NVIDIA's 61-year-old co-founder and CEO, Jensen Huang, who has no doubt AI is about to change everything.
Advanced Micro Devices, AMD, was watching. AMD made CPUs and GPUs, and it had spent years as the distant second-place competitor in gaming graphics. Now seeing NVIDIA's margins on data center chips, which were running above 60%, AMD launched its own GPU accelerated computing platform, ROCm. The problem, CUDA had a decade of head start. Every AI researcher, every framework, every model was built on CUDA. ROCm was technically capable, but the software ecosystem was tiny. Companies that tried to switch from NVIDIA to AMD discovered that their code ran slower, broke in unexpected ways, and required significant re-engineering. Most of them switched back. AMD's market share in AI chips has remained in the single digits despite years of effort and competitive hardware.
NVIDIA is seen as the dominant force in AI right now, and AMD is widely considered the next best option. Is that good enough for you? Do you like being seen as the underdog?
I wouldn't call it a like or dislike.
This is the most complex, highest performance
computer. Know that you are competitors. But do you ever trade notes?
Well, first of all, Jensen is brilliant, so I fully admire him for that. We were really distant, so we didn't grow up together. You know, we actually met at an industry event, so it wasn't until we were well into our careers.
The threat from Google and the most dangerous competitor, AMD's challenge, was manageable. Google's was existential. In 2016, Google announced the Tensor Processing Unit, the TPU.
When we talk about NVIDIA, it's mostly good news. But tonight, things are not so rosy for this company. On Monday night, a big headline shook up the tech world. Reports said that Meta was looking to buy chips from Google. On cue, the shares crashed. On Tuesday morning, NVIDIA was down by almost 7%, so NVIDIA decided that they had to do something about it. NVIDIA is a generation ahead of the industry. Google has been developing these chips, these TPUs, for more than a decade now.
You know what NVIDIA built is accelerated computing, not a tensor processing unit.
Tensor processing unit to run deep neural networks.
You might want to think about changing our courses and your research.
Custom developed, application-specific integrated circuits.
A custom chip designed from scratch for AI computation, optimized specifically for the mathematical operations that deep learning requires. Google did not build the TPU to sell it. Google built it for one purpose: to free Google from dependence on NVIDIA. Every time Google trained a new AI model, it paid NVIDIA. Every time it ran a search query through its neural network ranking system, it paid NVIDIA. The TPU was Google saying, "We are big enough to make our own chip."
NVIDIA is a phenomenal company. Jensen is awesome. We have been working with NVIDIA now for a very, very long time, and we continue to do so, right? And we serve a lot of the Gemini traffic on GPUs as well, right? And so we give customers choice, etc. Internally, we train our Gemini models on TPUs, right? And we serve it that way across our products, but we use both.
Amazon followed with Trainium and Inferentia. Microsoft invested in custom AI silicon. Meta developed MTIA.
The entire world would like more chips for doing generative AI. And whether that's GPUs or whether that's Amazon's own chips that we're designing, I think that we're in a better position than anybody else on Earth to supply the capacity that our customers collectively are going to want.
Amazon is not used to chasing the markets. Amazon is used to creating markets, and I think for the first time in a long time, they are finding themselves on the back foot, and they are working to play catch up.
Every major cloud company was attempting to reduce its NVIDIA dependency. The strategic reality NVIDIA faced, its best customers were building alternatives to it. Not because NVIDIA's chips were inadequate, they were still the fastest, but because no company wants to be dependent on a single supplier for the most critical input to its core business. While NVIDIA was managing the threat from hyperscalers, it faced a crisis of a different kind. Between 2020 and 2021, cryptocurrency mining, particularly Ethereum, consumed a massive share of NVIDIA's GPU production. Miners bought GPUs by the thousands to run the computational algorithms that validated Ethereum transactions. NVIDIA's gaming GPU inventory evaporated. Gaming customers could not buy cards at retail prices. Prices on resale markets went to 3 and 4 times retail. Then in 2022, Ethereum switched from proof of work to proof of stake.
Update now, a big change for the world's second largest cryptocurrency went live earlier today. Ethereum has completed a major software upgrade called the Merge to make its system more energy efficient. Well, the long-awaited upgrade changes the way it creates tokens from proof of work to proof of stake.
Proof of stake is a consensus algorithm. It's a consensus mechanism, I should say. It's the difference is that like an algorithm is something that you run by yourself. A mechanism is like it involves like interactions between people, and it could even include incentives and all of that.
Eliminating the need for GPU mining entirely. The mining demand collapsed overnight.
Well, absolutely, Liz. I think today was a historic day in crypto history, not only Ethereum history, but broader crypto history as well, with Ethereum migrating from proof of work to proof of stake. I think we have to understand the importance of this change that took place. I mean, Ethereum as the second biggest digital asset, as you just mentioned, has over $200 billion in market cap.
Hundreds of thousands of secondhand mining GPUs flooded the market. NVIDIA's gaming revenue fell sharply. NVIDIA had made a calculation error. It had assumed crypto demand was durable and had calibrated its production accordingly. When it collapsed, the company had too much inventory and not enough gaming revenue. November 30th, 2022, the day NVIDIA won. On November 30th, 2022, OpenAI released ChatGPT to the public.
OpenAI is set to introduce advertising on ChatGPT.
ChatGPT.
ChatGPT. First few weeks, it was like constantly. My kids will never be smarter than AI.
1 million users signed up in the first 5 days, 100 million in 2 months. It was the fastest product adoption in the history of the internet. Every technology executive on Earth immediately understood that large language models, AI systems trained on enormous data sets to generate human-like text, were about to become the core of every major product. Google declared a code red. Microsoft invested $10 billion in OpenAI. Meta announced a doubling of its AI research budget. Amazon re-architected its entire cloud product strategy around AI. Every single one of those AI programs required NVIDIA chips to run. ChatGPT was trained on NVIDIA A100 GPUs. Its successor, GPT-4, required NVIDIA H100s. Google Gemini, Claude. Every major AI model in existence was trained on NVIDIA infrastructure. In the 12 months following ChatGPT's release, NVIDIA's data center revenue grew from $11 billion to $47 billion annually. Its stock rose 230%. Its market capitalization went from $500 billion to $3.34 trillion. The company that had been 3 months from bankruptcy in 2002 now generates more free cash flow per quarter than most countries generate in annual GDP. The ChatGPT moment revealed something that even NVIDIA's competitors had underestimated. CUDA was not just a software framework, it was an entire ecosystem. By 2023, CUDA had been in development for 17 years. Over 4 million developers had learned to program with it. Over 3,000 software libraries were built on top of it. Every major AI framework, PyTorch, TensorFlow, JAX, was optimized for NVIDIA GPUs through CUDA. Every AI researcher in every major university had learned CUDA. When the AI supercycle began, companies did not evaluate whether to use NVIDIA chips. They used NVIDIA chips because their entire software stack assumed NVIDIA chips. Switching would require rewriting years of code, retraining engineers, and accepting lower performance, while competitors using NVIDIA chips moved ahead. Google's TPU remained superior for Google's specific internal workloads, but startups, research labs, and enterprises building AI products on standard frameworks all defaulted to NVIDIA. The hyperscalers had escaped the NVIDIA trap. Everyone else was still in it, and needed to be, because NVIDIA's ecosystem had no viable replacement. NVIDIA's current position is the strongest of any technology company in modern history, but history is full of dominant technology companies that were disrupted. IBM dominated computing until it didn't. Intel dominated chips until it didn't. Nokia dominated mobile until it didn't. Risk 1. Custom silicon scales. Every major cloud company is building custom AI chips. Google's TPU is already superior to NVIDIA for certain Google workloads. Risk 2. The next architecture shift. CUDA was built for transformer-based AI models. The architecture behind GPT-4, Gemini, and every major language model. If the field moves to a fundamentally different architecture, one that does not map well to GPU parallelism, NVIDIA's hardware advantage could disappear. This has happened before. The shift from rule-based AI to neural networks invalidated an entire generation of specialized hardware. Risk 3. Geopolitics. NVIDIA's most advanced chips, the H100 and its successor, the B100, are banned from export to China by US government order. China is NVIDIA's second largest market. The ban has already cost NVIDIA an estimated $12 billion in annual revenue. If China successfully develops its own AI chip ecosystem, Huawei's Ascend 910B is the current best attempt.
According to researchers from Peking University, the device could work 1,000 times faster than top digital processors like NVIDIA's graphics processing unit.
It eliminates NVIDIA from the world's largest AI market permanently. NVIDIA's story is not primarily a story about chips. It is a story about a CEO who understood in 2006 that the way to win a technology market was not to build the best product.
The role of a leader is not only to point people in the right direction, but it's to motivate them to get there, to give them a vision of the future, give them a vision of what success looks like.
It was to build the platform that everyone else's products were built on. If NVIDIA owned the platform, CUDA, then every application built on CUDA was a customer it could never lose. Apple understood this with iOS. Microsoft understood this with Windows. Google understood this with Android. Jensen Huang understood this with CUDA. And he understood it 16 years before the AI supercycle made it obvious. The question every technology investor, every entrepreneur, and every business strategist should be asking right now is this. In the AI era, who owns the next platform? NVIDIA built its platform for 16 years before anyone noticed. By the time they did, it was too late to replicate it. Jensen Huang lost half his revenue in 2002. He bet what was left on an idea nobody believed in. He spent 16 years building something that looked, for most of that time, like expensive altruism. And then the world caught up to him. The question is, who is doing the same thing right now that we cannot see yet? If you think NVIDIA's dominance lasts another decade, or if you think custom silicon ends it sooner than anyone expects, drop your take in the comments below. And if you enjoyed this breakdown, subscribe so you do not miss it.